Welcome back. Let's continue with question 15 from the multiple choice section. The equation cosine 2 theta plus d cos theta plus e has solutions as indicated. So at 0, pi over 3, 5 pi over 3, and 2 pi in the interval between 0 and 2 pi. So we need to find out what the values of d and e are. So in this case, the way you would approach this question is by first use the solutions to identify or to find out more about the coefficients d and e. So if the solutions are at angles 0 and pi over 3, 5 pi over 3, 2 pi, it means that if you substitute theta by either one of these values, then the equation will turn true. So I'm going to start off by using the first solution, 0. So that means that we have cosine of 2 times 0, that is 0, plus d times cosine 0, so that's cosine 0, plus e equals 0. Now, know that cosine of 0 is 1. D times cosine 0 then will be d times 1, so plus d, and then plus e equals 0. So we have discovered the first relationship between d and e, so we'll write d plus e equals negative 1. So that's the first equation. So this won't be sufficient enough for us to figure out the values of d and e. So that means we have to use another solution. So as you can see here, 0 and 2 pi will give us the same connection between d and e because at 0 and 2 pi, the cosine will have a value of 1. So that means that we have to use pi over 3 and 5 pi over 3 next. So I would use pi over 3. So we have cosine of double pi over 3 plus d times cosine pi over 3, and then plus e equals 0. So cosine double pi over 3, that's 2 pi over 3. So if you look at the angle pi over 3, that's the angle 60. So 2 pi over 3 would be double 60 or 120. Or even better, it would be this angle right here. So the cosine of 60 is 1/2. The cosine of 120 is negative half. So this will make negative 1 over 2. Then plus d. Cosine of pi over 3 is 1/2 plus e equals 0. So as you can see here, we have a denominator of 2. So that means we can eliminate the denominator by multiplying by 2 every term in the equation, both sides. So the first term will turn to a negative 1. The second term will be plus d. The next term is 2e equals 0. So 2e plus d equals positive 1. This will be our second equation. So now we have two equations with two unknowns. We can put them together in the system to solve for d and e. So I will bring the blue equation, d plus e equals negative 1, down here. And in the meantime, rearrange the terms. So we have 2e plus d equals 1, and e plus d equals negative 1. You can solve this system by elimination. If you subtract the equations, we get e plus 0d equals 1 minus negative 1, 2, which makes e equal to 2. If e equals 2, knowing that d plus e equals negative 1, then we're going to say d plus 2 equals negative 1, which makes d equal to negative 3. So we'll say that e equals 2 and d equals negative 3 are the solutions. So d equals negative 3 and e equals 2 is the very first option here. So we'll say the answer is A. Question 16. What is the equation of the following function? As you can see here, we have a periodic function, so either a sine or cosine. It seems that all the options in this case are sine. In order to find the equation of a function, remember that we have talked about all the steps. We identify the max and the min. The reason why is because we want to know where halfway between the max and min is so that we can draw the axis of symmetry. So with a maximum at 0 and minimum at negative 4, then the axis of symmetry will pass halfway between min and max, which is at -2. So y equals -2 is the axis of symmetry, and that will make the coefficient c, which is -2. So as you can see here, we have -2 in these two options, which means that we don't even have to look at these three other ones. So I would cross them out during the exam. So my focus stays only on the good or possible options. So next we have to decide on the equation. Remember, there is more than one equation for each function, for the same periodic function. So I would start off with the coefficient A. Coefficient A, or the amplitude, indicates the distance of max or min, for that matter, from the axis of symmetry. As you can see here, that distance is 2 units. If you look at both possible options in here, we have an amplitude of 2 here. An amplitude of 1/2 is impossible. So therefore, we're going to say that our good option here is A, and that would be the correct answer. Now, if this question had, for example, the same leading coefficient or the same amplitude, then what you would have to do is check the rest of the coefficients, obviously. We'll continue with question 17. Which of the following is true? Y equals tan theta is periodic and even function. If you recall the graph of tan, at angle x equals 0, the tan has a value of 0. So the way tan behaves is this. So this is not an even function. It actually exhibits odd symmetry. Y equals tan theta is periodic and odd. So that is correct because it is both periodic and odd. But I would continue reading all the options just to be sure. Y equals tan theta is the inverse of cotan theta. As a matter of fact, tan and cotan are related, but they're not inverses of each other. They're reciprocals of each other. So this is not true. Y equals tan theta is not periodic, so I would stop here and say, no, that's not true. Tan is a periodic function, so no need to continue reading it. And tan theta is not periodic, which means that I'm super confident that option B is the correct answer.